Welcome back. Today is day 4 of our trigonometry unit. In this lesson, we'll be applying the trigonometric ratios to solve for missing side lengths of triangles. Hope you enjoy the lesson. Oh yeah, it's that time again. We have some math problems here and we need you to do them now. Pause the video, complete the problems, and return to the video when you're done. It says find the trigonometric ratios for the right triangle. And remember we told you there's a mnemonic that we can use to help us with this one. We could use a nice easy one to remember. So, ka and toa. Alright, perfect. So in this problem, here's what we're looking for. We're going to actually have to figure out, we need to figure out what the reference angle is. So remember that when we write our functions, so right here, b, this is our reference angle. So when we say cosine of b, sine of b, tangent of b, we're referring to this reference angle. So let me just write that in. So this is my reference angle. Reference angle. Okay, that's as good as I can get right now. All right, so there's my reference angle. So I'm going to mark that with a theta. So I'm going to say, okay, there's theta, there's my reference angle. Now, once you know that, and we're just trying to find the trigonometric ratios, we just want to know what the ratios are. So we're looking at this problem like, what are the ratios? So for this problem here, we're going to say the ratio, and remember what sine is. Sine tells us that we have a ratio of your opposite side to your hypotenuse. So let me label, based on this reference angle, where everything is. So this is my hypotenuse, because that's across from the 90. So we can see that across from the 90 degrees. There's your hypotenuse. And these other two pieces over here, this is your opposite. That's my opposite side, my opposite leg, and this is my adjacent leg. So there we go. Now that we know that, now we're just going to write some ratios. And this little mnemonic up top tells us that, you know what, sine is the opposite over hypotenuse. So it makes it easier for me so I don't have to memorize it. So opposite over hypotenuse, which means that it's going to be just b over a. Okay, and let me write this out the long way. So again, usually when I start these problems, I usually start off by writing out the whole thing. So I write sine of theta is equal to opposite over hypotenuse. Okay, so I usually start out when I do these problems, I write that first. All right, and then I do all my substitution. The reference angle is in the parenthesis and my ratio is on the right side. So let's try the next one. Cosine. How about I write that first? So what is cosine? So cosine of theta is equal to, and I can look up here from the top, and it's a over h. So it's going to be adjacent over hypotenuse. That's the ratio. All right, perfect. And let's do the tangent one just real quick since we already started those two. So tangent is going to be, well, let's take a look. It's the O over the A, which is opposite over adjacent. So these are my ratios. All right, so now once we know those, we should be able to write these ratios no problem. So cosine of theta is going to be adjacent over hypotenuse. So let's find the adjacent, which is going to be this one, A. So A goes with A. That's pretty cool. And your hypotenuse is C. That's all we're doing. They just asked us to write ratios. What's the ratios for each one of these? Tangent of B. Well, tangent is opposite over adjacent, so that's going to be that's going to be B over A. Maybe this was a little confusing because we have letters everywhere. It probably makes it a lot easier if we just had numbers. If we put some numbers in there, you're probably like, okay, I got this. Not too bad. All right. Nice little review for us. Let's go on. Let's see what we're doing. So in this lesson now, we are actually going to be using what we've been learning, our trig ratios, and what we learned from our first investigation unit. How do we find the missing side lengths? So as you can see in this problem, I have a missing side length, that's x, and I need to find a way to solve it. So let me label a couple things real quick. So first thing, I have a reference angle here. There's a reference angle given that's 27 degrees. So there's my reference angle, and that tells me that this is my opposite piece, and this is my hypotenuse. So one of the key things to do in all these problems is to be able to label that triangle and then figuring out what ratio you're going to use. So now I'm going to say, okay, let's try this. So and it's nice when you guys start, when you don't have to write this down every time. So which ratio should I use if I'm trying to find the missing side x and I know the side of 15? Well, we're going to use this one. This is the ratio because it has the O and it has the H. So that's the ratio we're going to use. So let me write this out. So sine of theta is equal to opposite over hypotenuse. So there we go. Perfect. Now, once you're here, then you can start just doing a little substitution and plug it in and see if this makes sense. Let's see if we can solve this. So sine of theta, what's my reference angle? Well, your reference angle is 27 degrees. Perfect. And my opposite side is, that's what we're trying to figure out. And my hypotenuse is 15. And basically, if you can get here, you're almost done. We can solve this a bunch of different ways, but let me show you, why is this making sense? Why does this make sense? But in order to see why this makes sense, we need to kind of look at another app. So we need to go back to one of the apps that we started with earlier. So let me go back to the app. All right, so recall what we did here. This app was helping us to see like the ratios given the triangles that we have here. So I'm going to create a triangle, a right triangle with a 27 degrees. I'm going to get it as close as I can to 27 degrees as possible. And right there. Oh, missed it. How about a little bit lower? Right there. That's as close as I can get. Okay. So now I've created a right triangle with a reference angle of 27 degrees. And guess what? If we check this ratio, if we check the ratio between the opposite piece and the hypotenuse, we should get a value for this problem. Let's see what we get for this problem. So we're going to get a value of, and it tells us about 0.455. All right, so now, why is this important? Because this is what we're figuring out. So in this problem, it doesn't matter, let's see, if I made my triangle bigger or smaller, you can see that the ratio is not changing. I could have a small triangle, I can have a big triangle, but as long as that reference angle is 27 degrees, that ratio is staying the same. So now, when I go back over here to my problem, when we go back over here, we know that sine of 27 is going to give us some value. There is some value that we can get from that problem, and I think we said it was about 0.455. I think that's what the app said. So just from the app, we said, okay, well, this ratio, well, that has to equal the ratio that's on our problem here. So it has to equal this ratio. And that's basically what we're doing. All we're saying is, you know what? A triangle that has a reference angle of 27 degrees, the ratio between the opposite and the hypotenuse will be equal to this value. So we're able to write an equation. All right, so all our problems are going to be set up the same way. We can actually multiply both sides by 15, multiply both sides by 15, and get some value. Let's see what that value is. It says it's about, so I'm getting for this value about 6.825. Okay. Now, so all right, so we're going to use our friend GeoGebra to help us solve the equation that we just wrote. So we're going to type solve, just type the word solve and parentheses, and inside the parentheses, write your equation. So sine of 27 degrees is equal to x over 15. X divided by 15. And press enter. And there's my answer. That's a beautiful answer. Solved us nice. But you know what? That's not going to really help us out right now. I want to know how many, what's that as a decimal value? So you can click on this little button, and mine is going to round to this many decimal places. You could change your settings to how many decimal places you want it to round to, but it's going to tell me my answer is 6.809. So 6.81 would be a good sufficient answer. All right. So here's our picture. The same kind of problem. We want to find a side length. We have a reference angle here, so there's a reference angle that's 56. I can label the sides of my triangles, so now I know this is my adjacent piece and this is my hypotenuse. So using that, I can figure out what ratio I should use for this problem. So, oops. So, whoa, when did I change colors? So, ka and toa. And eventually, once you get good at this, you won't need to actually write this down. But let's see. If I'm trying to solve a problem and I have an adjacent piece that I'm trying to figure out and I know the hypotenuse, that means I'm going to be using the A and the H. So it's not going to be sine. It's not going to be tangent. It's going to be this one here. It's going to be cosine. So again, remember what I said. I always write it out the first time. So I write it out completely. So cosine of theta is equal to, what is that equal to? That's A over H. And there we go. That's how simple these problems are going to be. Write equation, figure out what ratio you're going to use, and then we'll go and solve it. Now let's do a quick substitution. So cosine of 56 degrees, perfect, is equal to x over 33. Now again, I'm going to stop right here because you know what? Technology will get us the rest of the way. So I'll let technology solve this one for us, and then you can record your answer right there. All right, for problem number 2, let's try problem number 2 now. So let's see if we can have GeoGebra help us solve that one. So again, we're going to write it out, solve, and we're going to do the same thing. Write your equation inside the parentheses. So cosine of 56 degrees is equal to x divided by 33. And again, let's get the decimal approximation of this. And my answer says it is 18.45. All right, here's our problem. I see I have a reference angle of 60 degrees. I can see that this is my opposite piece and this is my adjacent piece. Here's my hypotenuse, but I don't need it. If you want to label it, go ahead, but I don't need it. I'm looking for the ratio that uses the opposite and adjacent. So which one of these ratios, the sine, the so, ka, or toa, uses the opposite and adjacent piece? Well, it's going to be this one. Tangent is actually the ratio of opposite over adjacent. So let's write it out. Tangent of theta is equal to opposite over adjacent. And there we go. Quick, simple, easy. We got this. Let's substitute our values in. So tangent of theta is equal to what over what? Let's see. Tangent of theta is equal to opposite over adjacent. So that's 100 over 100 divided by x. Perfect. And again, if you can get this far, you're basically done because we are going to use our friend GeoGebra to solve this for. So we're going to say, GeoGebra, can you solve this equation for me that I just wrote? All right, problem number 3. Let's go ahead and continue on where we left off. So again, how do we do it? Just type the word solve and then record your equation inside the parentheses. So tangent of 60 degrees is equal to 100 divided by x. And there's the exact answer, but I want a decimal value. So give me a decimal value, and it says it is 57.7 degrees. All right, and then we'll call it a day. All right, so find the values of x. Same type of problem. We have reference angles, we have sides. Here's my reference angle. If that's my reference angle, then this is my opposite piece, and this is my hypotenuse. All right, this piece over here is my adjacent piece, but I don't need that one. I'm not looking for adjacent in this picture. I'm looking for the hypotenuse. And again, which ratio are you going to use? So let's write them out. So, ka and toa. Which ratio are you going to use for this problem? Well, again, if I need the opposite and the hypotenuse, that looks like I'm going to be using sine. So I'm not going to use these two over here. So the ratio that I would use is sine. So sine of theta is opposite over hypotenuse. You'll start getting faster and faster as you do these problems. So sine of 36 is equal to, opposite is 15 over x. And guess what? GeoGebra, my friend, can you solve this for me, please? All right, for wrap up today, can you guys just summarize what you learned today? Summarize what we learned how to do today, what we're trying to figure out, what was the key ideas, anything that was important to you, like into remembering and understanding how to do this. All right, thank you. Hope you enjoyed the video.